students, I hope we are all doing superb and good. So today we are going to learn about the topic is matter around us, pure. In this chapter we are going to learn about the types of matter, and we are also going to see briefly about pure substance and mixture. And finally we are also going to learn about the separation of components from the mixture under the topic is matter around us, pure. So let's begin the class. So what is meant by matter? Anything that occupies space are called matter. Based upon the physical state, matter is classified under three types, that is solid, liquid and gas. Based upon the chemical composition of matter, which has been classified under two types, that is pure substance and mixture. Now we'll briefly discuss about the types of pure substance. So pure substance are of two types, that is elements and compounds. So what is meant by element? Element is the basic form of matter which cannot be broken down into simpler substance by chemical reactions. So elements are of three types. They are metals, non-metals and metalloids. So now we'll see some properties of metals. They have luster, they are malleable, which can be converted into thin sheets, and ductile, which can be converted into thin wires. They are good conductors of heat and electricity, and they are sonorous in nature, which makes noise. So example, iron, aluminium, zinc, mercury, copper, silver and gold. Now let us see about non-metals. Non-metals not have luster, they are not malleable or ductile, they are poor conductors of heat and electricity, they are not sonorous in nature. Example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur and phosphorus are the examples of non-metals. So what is meant by metalloids? Metalloids are elements which show properties of metals and some properties of non-metals. Example, boron, silicon are the example of metalloids. Now, what is meant by compound? A compound is a substance consists of two or more elements chemically combined together in a fixed ratio. Example, water, carbon dioxide, sugar and salt. Now let us understand what is meant by pure substance. Pure substance are the substance which consist of single type of particle. Example, iron, copper, hydrogen are the examples of pure substance. Then what is meant by mixture? Mixture is a substance which consists of two or more substance. Example, sea water, mineral, soil, air are the examples of. Now let us see the types of mixture. Mixtures are of two types, that is homogeneous mixture and heterogeneous mixture. So what is meant by homogeneous mixture? Homogeneous mixture is a mixture which has uniform composition. When I am talking about heterogeneous mixture which has non-uniform composition, the mixture which is in non-uniform composition. So now let us know briefly about homogeneous mixture and heterogeneous mixture. Homogeneous mixture is a mixture which has a uniform composition. The particles of the mixture are not visible by the naked eye. The particles cannot be separated by the filtration method. The mixture is very stable, that is the particles do not settle down. When I am applying a beam of light to pass through it, the homogeneous mixture, inside the homogeneous mixture, the path of light is not visible. So example, mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water.
When I am talking about heterogeneous mixture, which is a mixture which can able to see, the particles can able to see by the naked eye. The particles can be separated by filtration method. The mixture is unstable. The particles always settle at the bottom. When I am allowing the path of beam of light is visible in the mixture. Example, mixture of salt and sand, mixture of sulfur and iron filling, and mixture of oil and water are the examples of heterogeneous mixture. Now, let us understand the concept of true solution. What is meant by true solution? A true solution is a homogeneous mixture of two or more substance. So here a solution has two parts. One is solvent, other one is solute. The component in the larger amount is the solvent and the component in the lesser amount is the solute. For example, when I am having water and salt, the solvent is water and the solute is salt. Example, let me give the example for true solution. Solution of salt in water, solution of sugar in water and iodine in water are the examples of true solution. Now let us understand the properties of true solution. True solution is a homogeneous mixture which has uniform composition. The particles cannot be seen by the naked eye. We cannot able to see through the naked eye. The solute particles cannot be separated by filtration because which completely mix into the solution. The solute particles do not settle down because which completely mix in the solution, and the solution is very stable. The particles do not scatter a beam of light passing through it, and the light is not visible in the mixture. When I am talking about colloidal solution, a colloidal solution is a heterogeneous mixture of two or more substance. Example, mixture of salt in starch in water, mixture of egg albumine in water, and even milk are the example of colloidal solution. Understand the properties of colloidal solution. Colloidal solution is a heterogeneous mixture which has non-uniform composition. The particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is always stable. The particles scatter a beam of light passing through it and the path of light is visible in the solution. Now, let us understand about suspension. A suspension is a heterogeneous mixture of two or more substances. Example, solution of sand in water, solution of chalk powder in water. Now let us understand the properties of suspension. Suspension is a heterogeneous mixture. The particles can be seen by the naked eye. The suspension in which the particles can be seen in the naked eye. For example, whenever you are going to the doctor will be prescribing a suspension. The particles can be seen by the naked eye. The solute particles can be separated by filtration technique. The solute particles settle down and the solution is unstable. So when I am applying a beam of light through the suspension, path of light is visible in the solution. Now let us understand the meaning of Tyndall effect. So what is meant by Tyndall effect? When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution. This effect is called Tyndall effect. Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by the dust and smoke particles. So Tyndall effect can be seen in a dense forest due to scattering of light by water droplets in the mist. So these are the examples of Tyndall effect. Now we'll see what is meant by saturated solution. Saturated solution is a solution which cannot dissolve any more of a solute at a given temperature. So here we have to understand about solubility. So what is meant by solubility? Solubility of a substance is the amount of solute present in a saturated solution of a substance. Then what is the meaning of unsaturated solution? Unsaturated solution is a solution which can dissolve some more of the solute at a given temperature. Now we are going to calculate the concentration of a solution. So for the calculation of the solution, concentration of a solution, we need two things. We need amount of solute as well as the amount of solvent. So the concentration of a solution can be expressed as mass by mass percentage or as mass by volume percentage. When I am writing, we are going to understand the separation of components of a mixture. The components of a heterogeneous mixture can be separated by simple methods like hand picking, sieving and filtration. But sometimes we need special techniques are used to separate the components of a mixture. Example, evaporation, centrifugation, decantation, sublimation and chromatography, distillation and fractional distillation. Evaporation is a technique. Here I am going to use volatile component and non-volatile component. So here I am going to separate a volatile component, that is a solvent, from a non-volatile component called solute by heating the mixture. Example, here I have taken ink. Ink is a mixture of dye and water, you know very well. If some ink is heated in a dish, what will happen? The volatile component evaporation will be taken place. That is, the water evaporate because which is volatile in nature, which can evaporate, and the dye is a non-volatile component which cannot be evaporated, and the dye is left in the dish. Similarly, we can separate mixture of salt and water or sugar and water by evaporation. What is meant by centrifugation? The method of separating the denser particle, the denser particle and lighter particles from a mixture by using a centrifuging machine is called centrifugation. So here I am going to separate the high dense particle from the less dense particle. So here I am going to take the example as milk. So I am going to take the milk in a centrifuging machine and I am going to spin it very rapidly. Now the cream separates from the milk because the cream is less dense particle which separates, which floats on the milk. Because now the next technique is called decantation using separating funnel. So this method is used for separating a mixture of immiscible liquid which doesn't mix together. So liquids separate into different layers depending on their densities, we know very well. Example, if we take an example of kerosene and water in a separating funnel, you know very well, which doesn't mix together, which forms separate layers of oil and water. Now the water can be separated by opening the stopcock, and after the water flows out, the stopcock can be closed. In this manner I can separate the two immiscible liquids. The next method is called. Now let us understand the meaning of sublimation. So what is meant by sublimation? Here the solid will be converted into gas. So without coming to the stage of liquid is called sublimation. So this method is used to separate a mixture of a sublimable component from a non-sublimable component by heating the mixture. Example, if I am heating the mixture of ammonium chloride and common salt, the ammonium chloride sublimes, which means what? Which can convert into gas directly. The solid will be converted into gas and can be cooled and solidified, so that again the gas will be converted into the vapors coming from the ammonium chloride will be converted back to the solid and collected, and the salt is left behind. So this is the process of sublimation. Now we are going to learn about the process of chromatography. So this method is used for separating colored components from a liquid. For example, a dye may contain one or more colors. So if I want to separate all the colors which is in the dye by using a filter paper or blotting paper, I can use this technique called chromatography. Here I am going to put a drop of ink near one end of a strip of filter paper, and I am going to dip the end of the paper in a test tube which contains water. Now, as we know very well, the ink is a mixture of two or more colored component. Here when I am placing the filter paper into the water, the paper strip will absorb the water, so that the component which is more soluble in water, the color will rises faster and the color gets separated faster. You can find the different color bands based upon the solubility of the component. We are going to learn about distillation. So this method is used for separating a mixture of mixable liquid by boiling the mixture. So I am going to boil the mixture because two things has been mixed together, so that may be vary in their boiling point. That is why I am going to heat the mixture and cooling and condensing the vapor. Now we'll see simple distillation technique. Simple distillation technique is used for separating a mixture of two miscible liquids having difference in their boiling point. Example, if a mixture of acetone and water is heated in a distillation apparatus, now first acetone, which has a lower boiling point than the water, which first boils and then which comes through the condenser and which cools, and it's separated from the water because which differs in their boiling point. Now we are going to learn about fractional distillation. So here the fractional distillation is used for separating a mixture of two or more miscible liquids. So I am having two or more mixable liquid which has been mixed together but which differs in their boiling point, which is less than 25 K, so that I can use a technique called fractional distillation. So here the apparatus used for fractional distillation is similar to the top used for simple distillation, but except I am having a separate column called fractionating column is fitted between the two things, between the distillation flask and the condenser. I am going to fix a fractionating column. So here the fractionating column is fixed with glass beads, which increases the surface for the vapors to cool down and also to condense. So here the fractional distillation is used for separating even the components of petroleum and also used to separate the different gases from air by using this technique called fractional distillation. Now we'll see how the separation of components of air will be taken place. We know very well air is a mixture of many gases. Now the components of air can be separated by fractional distillation method. Now here in this method air is compressed. I am going to compress the air by increasing the pressure, and also I am going to cool it by decreasing the temperature so that I can get the liquid air. Now the liquid air is warmed up slowly in the fractional distillation column. So here then the different components will separate at different heights based upon their boiling point, through which I can separate the components of air. We'll see the next technique called purification of solid by crystallization. So now we know very well crystallization is the process of obtaining a pure solid in the form of crystals from its solution. In the same method we are obtaining our salt. crystallized salt. So example, crystallization. By this method, crystallization, we can obtain pure copper sulfate from its solution. For this, I am going to dissolve 5 gram of copper sulfate in water. So now I am going to filter the solution so that I can remove the impurities present in the copper sulfate solution. Now I am going to evaporate the solution. For that I am just going to pour the solution in a china dish so that the solution, the water present in the solution will get evaporated. Now I am going to cover the solution with filter paper so that the filter paper absorb the water solvent present in it, and I am going to allow it to cool for few minutes. So after few minutes, if I remove the kissed filter paper, I can able to see the pure. So my dear students, today we have briefly discussed about the lesson is matter around us pure. I hope you have all understood. Thank you everyone.